Welcome dear students for the online class of 3rd semester BCA of the subject System Software pertaining to the Kuvempu University. So today in this online session we are having the session number 16 coming from unit number 2 for the unit titled Assembler and Loader, and in our today's session we are going to discuss about the flowchart for the pass 1. So before moving on to that, let us have a recap of our previous class. So in our previous class, that is in our previous session, we understood the algorithm for the pass 2 and we understood the concept of look for modularity. So today's class, the learning objective will be getting the overall understanding and explanation of the flowchart of the pass 1 along with its complete explanation. So the session outcome will be the student will be able to understand the flowchart of the pass 1 of an assembler. So let us start the discussion about the pass 1 of the assembler. So in the previous class we have learnt what is the pass 1 is going to do in the assembler and what are the data structures we are going to use and what is the databases we are going to use in both the pass 1 as well as in the pass 2. So today we will understand with the flowchart how the pass 1 is going on. So before that, let us have some of the important points which I have already learnt about the pass 1. So I'll just revise you that the first one is here for doing the work in the pass 1 we should have an input source program. So next, once we get the input source program, the important thing here is we need to have been initialized with the location counter value. That is the location counter which is utilized to maintain the track of every instruction's location, which are really needed for the processing of every instruction in the further pass 2 also. Then we need MOT, that is machine operation table, which signifies the symbol mnemonics for every instruction and its associated length, which may be in 2 bytes, 4 bytes or 6 bytes and so on. So next, another important thing what we have is the POT, a directive or a pseudo operation table, which will signify the symbolic mnemonic and the action to be taken for each pseudo op in our pass 1. Along with this MOT and POT, we know that we need ST, that is symbol table, which used to amass each label and its equivalent value there. Along with this symbol, another important entity for our pass 1 and pass 2 is literals. So for that, we need to have a literal table which utilized to amass each literal encountered and its matching assigned location. Then finally, at the end of this pass 1, we should have an accurate copy of the input which is saved for the use by the pass 2. This may be accumulated in a secondary storage devices like or a disk or anywhere a structure in a main memory. So with this information, what all the things we need to have in our pass 1, let us directly go for having a diagram which is depicting the algorithm of the pass 1 in terms of a flowchart. Okay. So let this slide, it depicts the flowchart of assembler pass 1. So you already know what is a flowchart. A flowchart is nothing but it's a symbolic representation of flow of execution of any particular process. The same way in the flowchart, you know, we use different symbols. We use some of the specified symbols to specify the starting of the flowchart, some to specify what are the different operations being used, and you know why the arrow marks are being used. So with the knowledge of the flowchart, let us understand the flowchart for the assembler number 1, that is pass 1. So first we'll have the start the pass 1. So once the pass 1 of an assembler is started, we will get the user line from the file, that is we are going to scan the source code. Okay, from there we are going to check whether it has a label, that is label is present. If you encounter with a label, then that label will be taken to the add to the symbol table. Okay, then that after storing that particular label in the symbol table, we are going to add to the user report. Now assume that we have scanned the source code and we have checked for label, it is not present, then the next thing is we'll go forward searching the directive table. And even from add to symbol table, we'll coming back to the work for searching the directive table. Once the directive table is checked, if you don't find any of the label and the directive, we'll go to the end, we'll exit the pass 1 and we'll go to the pass 2. Else we'll go for searching instruction table. we'll check it. If an instruction is obtained, then we'll go for determining its length. Otherwise, from the end will come to invalid and will create a NOP for the invalid instruction. Okay. So then from again there we'll be moving back to the first step in our flow chart. If it is false, then we are going to determine the length of the instruction table. Then we'll check for the literals. So if you found a literal, we'll add into the symbol table. From there we'll go to add to the intermediate version, and finally we are using the updating the or incrementing or updating the value of our LC, which stands for location counter. And from here this particular process of step 1 or pass 1 will be put up in a loop. It will be again we are doing the same work starting from the step 1, that is you have used a label A, you can see there. So we are again calling back to the label A, and we are going to perform the same operation again and again until the completion of our pass 1. So whatever the data we are getting from the pass 1, they will be stored in the secondary storage, and it will be given or fed to the pass 2 of our assembler. So this is a slide which is depicting the various operations which are being done in the pass 1 of the assembler. I think you got an insight and you're clear about what all the things one has to do in designing the pass 1 of an assembler. So let us have the MCQs. So the first MCQ is, in a 2-pass assembler, the pseudocode EQU is to be evaluated during when? Option A is pass 1, option B is pass 2, option C is not evaluated, and option D is none of the above. And the answer for 1 is it is done during the pass 1. Next, MCQ 2, the translator for low-level programming languages were termed as what? Whether they are termed as assembler, compiler, linker or a loader. So they are being termed as what? Assemblers. MCQ number 3, a single 2-pass assembler does which of the following in the first pass? That is, it is telling what the pass 1 is going to do. So see the options properly. First question, option number 1, it allocates spaces for the literal. Option 2, it computes the total length of the program. It builds the symbol table for the symbols and their values. All of the above. I think you know the answer, and the answer is D. That is, all the things which are been stated in ABC will be done during the pass 1 of your assembler. So next MCQ is, which of the following is not a function of pass 1 of an assembler? That is, it generates a data, keeps track of location counter, remembers the literals, and remember the values of symbols using pass 2. So the answer is A. So the pass 1 will be doing the option B, C and D, but A will not be done in your pass 1. So next MCQ is, in a 2-pass assembler pseudocode, EQU is evaluated during the pass 1, pass 2, not evaluated, and none of the other. And this is the same MCQ we had earlier, that is pass 1. So finally, in our today's online session, we have learned what is the flowchart for the pass 1 and how the operations are happening in the pass 1 with the help of a flowchart. So for further readings, you can refer the book authored by John Donovan, and the title of the book is System Programming. Thank you.